Take a look at this sentence. It says 50% of 12 is 6. Now the statement is true because 50% is really just 1/2 as a fraction, and we know that half of 12 is 6. But it leads us to a classic mathematical equation, and it's one that we're going to deal with quite a bit in this chapter. The mathematical equation is called a percent equation, and it goes like this. We translate the of in the English sentence into times for mathematical purposes, and is means is equal to. You see, so we transform an English sentence into a mathematical sentence, which is an equation. So 50% of 12 is 6, or 50% times 12 is equal to 6. Now, this percent equation is so common that we give a name to the various parts of it. And it's no surprise that the number involving a percent is called the percent. And generally, the percent is multiplied times a number called the base. And it is a quantity, it's kind of like a starting quantity in this kind of environment. And the number that we get as a result of this multiplication is called the amount. So percent base amount. A lot of times it's the case that the amount is a part of the base. Now that doesn't always happen, but we can think of it like that in most cases. Like here it is that way. 50% of 12 is 6. It's like we're starting with 12, we're taking a percent of it, and the amount that we get is a portion of the base, the amount that the quantity that we start with here. All right, so that's the structure of it. Now, the amount could be larger than the base if the percent number is larger than 100%. We'll see situations like that in a little bit. It should make some sense that if we have a statement of equality here, that what's on the left is equal to, has the same value as what's on the right, then certainly we could swap sides with this. So we might see this percent equation written with the amount on the left side and percent times base on the other side. And after all, here we could interpret this one that way, that the amount was 6 is equal to 50%, you see, of times 12. So we could write it like this. It makes just as much sense as it did before. When we deal with the percent equation, we're often looking for one of those three values. That is, we don't know something in that equation. Here's an example of that. This says 20% of 50 is what, or is what number? You see, and all we need to do is go through this interpretation process, form an equation, you see, and perform the operations that are implied within the equation. Now, this is 20% then, of means times 50 is equal to what means what number. We let a letter stand in for the number. We could let that letter be X or Z or A or B, whatever we'd like. I'll let the letter be N for this problem. So 20% times 50 is N. Now, it's easy to multiply here when we change the percent into either a decimal or a fraction. In some cases, it's more convenient to change into a fraction. In some cases, it's more convenient to change to the decimal. When we have digits like this, and it's a pretty simple looking percent, I think it's really easy to change into a decimal form. Here, to change the percent to a decimal, we take the decimal, which is here to the right of the 0, and slide it 2 places to the left. So this becomes 20 hundredths times 50 is equal to N. We perform the indicated operation. Let's do that. We have this times 50. So we have the 0 here, and then 5 times 0, 0, 5 times 2, 10. 2 digits to the right of the decimal, so 2 digits to the right of the decimal in the answer. It goes right here. So this product then is 10. So we put that information back into the equation format. Now, just because we find the value here doesn't mean we stop the problem. We come back into this equation format and finish it off, you see, with a correct answer. And what we're saying here when finding the value of N, we're saying that N can be replaced with 10 to make the original statement true. So we're saying here then that 20% of 50 is 10. All right, let's look at a couple of others. What is 125% of 12%? Now, in this interpretation process, in going from the English sentence into the mathematical sentence or the mathematical equation, we can exchange of for times and is for equals. That's true. We can also change the percent into more of a manipulative form, either a decimal or a fraction in the same step. For example, here, what number? That's in, is equal to, you see. 125% is 1.25. Of means times, and that should just be a 12 rather than 12%. All right, so we're taking 125% of 12, and so we're multiplying here. All right, and away we go with the multiplication. But you notice the transition here from the English sentence to the mathematical form. So it's this kind of thing. And now we multiply here to get 15. We find n to be 15, and we are answering the question above, that 15 is 125% of 12. Take a look at this one. Now, sometimes words other than the ones that are actually used up here can be interpreted in much the same way. That is, when we are told to find something, we're asking what number is this? So what number is 8.5% of 20? So what number is equal to 8.5% as a decimal is 0.085, and I know that by sliding the decimal point 2 places to the left and dropping the percent. It gives us this. Of means times, bring down the 20. Multiplying here, we find n to be 1.7, 1 7/10. Here's one where we change the percent into a fraction. It's more convenient to do that. And in fact, kind of as a rule of thumb, if you have a fraction in the percent, then change the percent into fraction form, generally. And we go through that process, remember, like this. Now, you'll come to recognize some percents as being equivalent to certain fractions. This is one of them. 33 1/3% is just 1/3. And let's see why that's the case. I'm coming out to the side here. Now remember, percent means hundredths, and we use that idea in making the transition. So this is 33 1/3. The percent is times 1/100th, you see. And then 3 times 33 is 99, plus 1 is 100. So this is 100 over 3 times 1 over 100. And oh, happy day, we get a nice cancellation here with the hundreds. 1 times 1, 1. 3 times 1, 3. So this is 1/3. So we come back over here, and in our next step, changing to either a decimal or a fraction, we're changing it into the fraction 1/3. Of means times. 15 is equal to what means what number. I'll let n stand in for that number. And now all we do is perform the indicated operation. We think of 15 as 15 over 1 for multiplication purposes. 3 into 3 goes 1. 3 into 15, 5. 1 times 5, 5. 1 times 1, 1. But 5 over 1 is just 5. And that is equal to n. This says, what is 16 2/3%? Excuse me, I'm having a little trouble writing my problems here. This should be 16 2/3% of 24. And we go through, again, the interpretation process. What means what number? So let's let x be the number this time. Is equal to 16 2/3%. Gee, we need to change that to a fraction because it has a fraction in it. Let's do that over here. Now, this is not one that is as obvious as the other, but it turns out to be a rather simple fraction. It's 16 2/3%. Percent means per hundred or hundredths. So it's 16 2/3 times 1/100th. 3 times 16 plus 2. Let's see. 3 times 16, gee, maybe I can't do that in my head. I'll come out here to the side and figure 16 times 3. 3 times 6 is 18. I'm carrying 1. 3 times 1 is 3, and 1 is 4. So 48. 3 times 16 is 48, plus 2 is 50. So this is 50 over 3 times 1 over 100. Now the 50 and the 100 can cancel. 50 into 50 goes 1. 50 into 100 goes 2. Multiplying straight across, 1 times 1, 1. 3 times 2, 6. So 1/6 is the fraction corresponding with 16 2/3%. So this 16 2/3% is replaced with 1/6. Of means times. 24 is 24 over 1. And now we look for the cancellation. 6 into 6, 1. 6 into 24, 4. Multiplying straight across, we find x to be 4 over 1, or more simply, just 4. Now sometimes we're asked to determine what number is larger in this percent situation. A problem like this might crop up. Which is larger? 5% of 95 or 75% of 6? Now, there's no need to guess about this kind of thing. And that's often the tendency that students might have. Well, you might look at it by saying, well, gee, 5% is so much smaller than 75%, this number must be smaller. Then someone else will say, no, 95 is a much larger number than 6, so the number over here must be larger. Well, we can't really tell. But we can tell if we perform the implied operation here. 5% of 95 means 5% times 95. 5% is 0.05 of times 95. You see, let's perform that operation and determine what the decimal is corresponding with this idea. So let's see, it's 5 times 5, 25, carry 2. 5 times 9, 45, and 2, 47. And now 2 digits lie to the right of the decimal, so 4.75 is 5% of 95. Now let's go calculate 75% of 6. This is 75 hundredths of means times 6. And away we go. 6 times 5, 30, carry 3. 6 times 7, 42, and 3 is 45. 2 digits to the right of the decimal here, 2 digits to the right in the answer, so this is 4.50. Now it's pretty easy to compare these two. They're the same at the whole numbered value, whole numbered digit. They both have 4, and now this has 7 tenths, that has 5 tenths, so this number is larger, so 4 and 75 hundredths is larger than 4 and 50 hundredths, or 4 and 5 tenths. So 5% of 95 is larger than 75% of 6. An RV sales center offers, wait a minute, what's this RV business mean? Well, RV means recreational vehicle. Recreational vehicle. So we can say that a recreational vehicle sales center offers a 7% rebate on the Road Trek model. What rebate would a buyer receive on a Road Trek that costs $24,000? Well, what does this word rebate mean? Well, rebate is simply an amount of money that someone gets back for buying this. It's what the dealer is giving back to the purchaser. So that's what rebate is all about. Now, this problem is all about the amount of that rebate. What rebate would a buyer receive on a Road Trek that costs $24,000? The key here is to kind of make a sentence, and it's kind of in the form of a percent equation sentence that deals with this rebate idea. It's telling us that we're being offered, if we're the buyer, we're being offered a 7% rebate on this item that costs $24,000. So we simply restate the problem like this. We might say that the rebate is, you see, the amount of the rebate is what we're looking for. It says, what rebate would a buyer receive? Okay, the rebate is, you see, we just make a complete sentence out of the thing that we're looking for. The rebate is, and what is it? It's 7% of the cost of this vehicle. And we can interpret this now like this. The rebate is means equals, 7% is 7 hundredths, the word of means times, and the cost of the vehicle is $24,000. Now multiplying 7 hundredths times 24,000, we find that rebate to be $1,680. And we write our answer as a complete sentence. A buyer would receive a rebate of $1,680 on a Road Trek that costs $24,000. A car company increased the average price of its new models by 2.4%. If the average price of the car was $8,245, what was the amount of the increase? Then it goes on with a second question, but let's answer the first question right now before we even consider the second question. What was the amount of the increase? The key here is to write what we're looking for. We're looking for this increase idea. Write a complete sentence involving the increase and how it is calculated. The increase is what? Well, it is a percent of that price. Or we could say then that the increase was 2.4% of the price of the car. And now we go from this sentence, this English sentence, into a mathematical sentence. The increase equals. You see, the equals is there because was is a verb form of is. And we treat it in the same way. So increase is equal to 2.4% becomes 0.024 as a decimal. Of means times. And the price of the car is given as $8,245. Now, multiplying on the right, we find the amount to be $197.88. And we write our answer as a complete sentence. The amount of the increase was $197.88. Let's answer the other part, the other question. What was the new price of the car? Now, let's see. How do we calculate new price? And in considering that, and the way that you think about it, and in thinking about it, begin to write something down. You think to yourself, well, gee, how do I calculate this? Well, I would take the old price, I would add the amount of the increase, and I would have the new price, and that's all there is to it. And in thinking that and in writing that down, you write down the old price of $82.45, the increase that we just calculated, add them together, and you find the new price to be $8,442.88. And we write the answer as a complete sentence.